In this video, we're going to introduce you to rational expressions. And a rational expression is when you have a polynomial divided by another polynomial. So for example, if I had 3x squared plus 2x minus 5, that's a polynomial, and I'm going to divide it by another polynomial, let's say x plus 1. Now, when we look at rational expressions, if we want to evaluate it, we can plug in values for x, but we have to be careful and make sure that we don't plug in a value for x so that we have 0 in the denominator, because when we divide by 0, that is undefined. So, in this specific example, I would say that we would have a restriction that x cannot equal -1, because if I plug in -1 for x, I'm going to have a -1 plus a 1 in the denominator, which would give me 0. And I can't divide by 0 because, as I said, division by 0 is undefined. So the first thing we're going to talk about is simplifying rational expressions. And when we simplify rational expressions, we're going to simplify it just like we do a numerical fraction. So if you think back of simplifying numerical fractions, we think back if I give you, for example, 8 over 24, and I ask you to simplify that. I think, well, 8 is 2 times 2 times 2, so we factor it. And then 24 is 2 times 2 times 2 times 3. And then what we do is we get rid of the factors that are the same on the top and the bottom, because 2 over 2 is just 1. So we can get rid of anything that is the same on the top and the bottom. Whatever we have left would be the reduced fraction or the simplified fraction. So we're going to use that same technique. When we simplify rational expressions, we're going to factor it, then we're going to cross off the factors that are in common in the numerator and in the denominator. So in this example here, if I factor the numerator, I can factor out a 2, and what I would have left is 5x plus 3y. Then I can factor the denominator and pull out a 2x, and what I would have left over would be x plus y. In the numerator, I have two factors. I have the factor 2 and I have the factor 5x plus 3y. In the denominator, I have three factors. I have 2, I have x, and I have x plus y. What they have in common is 2, so I'd cross off the 2's, and then whatever is left is my simplified expression. So I would have 5x plus 3y, and on the bottom I would have x times x plus y. And so this would be my simplified rational expression. In the second example, we have a squared minus 5a plus 6 in the numerator, and we're dividing by a squared plus a minus 6 in the denominator. So in order to simplify this, we need to factor the top and factor the bottom. When I factor the top, I'm going to get a minus 2 times a minus 3. And when I factor the denominator, I'm going to get a minus 2 and a plus 3. Now, if you notice, now that we have this factored, I can see that if I plug in a is 2, or if I plug in a is -3 into this expression, that's going to cause me to have 0 in the denominator. So I want to make sure that I say that my restrictions are that a cannot equal 2 and a cannot equal -3. Otherwise, this expression would be undefined. So going back to simplifying this, if I look after I factor it, I have a factor in common. A minus 2 is seen in the numerator and the denominator. So I can cross off a minus 2 in the numerator and the denominator, and what's left over is a minus 3 over a plus 3. So a minus 3 over a plus 3 is my reduced expression, and my restrictions is that a cannot be 2 and a cannot be negative 3. Okay, now going on to multiplication of rational expressions. If we think back about how to multiply fractions, when we multiply fractions, we multiply across the top, and then we multiply across the bottom. And then we can cancel out anything that they have in common on the top and the bottom. If I factor the numerator, I would have 2 times 3 times 3. And in the denominator, I would have 3 times 5 times 2. And then anything that they have in common, I can cross off. So I can cross off the 2, and I can cross off the 3 in the numerator and the denominator. So my final answer would be 3/5. So this is exactly how we're going to go about multiplying rational expressions. We're going to factor everything, combine the tops, and then combine the bottoms and cancel out what they have in common. So if I factor the first fraction of this product, in the numerator we have x squared minus 16. If I factor that, that would be x minus 4 and x plus 4. If I factor the denominator, x squared minus 9, that would be x minus 3 and x plus 3. Then looking at the second fraction, you can't factor that. That's already a linear factor. So I would leave it as x plus 3 and x minus 4. Now we're going to cross off what they have in common on the top and the bottom. On the bottom and the top, I have an x minus 4, so I would cross that off. And on the top and the bottom, I have an x plus 3. So I can cross that off as well. And if you notice, what is left is x plus 4 and x minus 3. So I would write my final answer as x plus 4 and x minus 3. In the next example, we have a product, and we have 3a minus 6 over a squared minus 16 as the first fraction. So let's go ahead and factor that. In the numerator of the first fraction, I can pull out a 3. So I would have 3, and then I would have a minus 2. The denominator of the first fraction is a squared minus 16, and I can factor that as a minus 4 times a minus 4. In the second factor of this product, in the numerator we have a squared minus a minus 12. If I factor that, I will have a minus 4 and a plus 3. And in the denominator of the second fraction, I have a minus 2, which is already completely factored, so I can just carry that down. Anything that the numerator and the denominator has in common, we can cross off. So we have an a minus 2 in common, I can cross that off. I have an a minus 4 in common, I can cross that off. And what's left is 3, an a minus 4 in the denominator, and an a plus 3. So when I write down my final answer, I'll write it as 3, a plus 3, and then all over a minus 4. In this last example for multiplying rational expressions, this is going to get a little bit messy, but it still is the same procedure where we have to factor everything and then cross off what the numerator and the denominator have in common. So let's start off by factoring the numerator of the first fraction. And in the first fraction, I can factor out a 2y, and what's left over would be 4x squared plus 25xy plus 25y squared. In the denominator of that fraction, I can factor out a 4y, and what I would have left over would be x squared minus 25y squared. Now, when I go to factor the second fraction, in the numerator, I can factor out an 8, and what I would have left over would be x squared minus 4xy minus 5y squared. And in the denominator, we have the sum of cubes so that we can use our formula for the sum of cubes for this. Using the formula for sum of cubes, when we factor, we would get 4x plus 5y, and then what would be left over would be 16x squared plus 20xy plus 25y squared. Now, let's continue factoring down here. It's not done. In the numerator of the first fraction, I can still factor 4x squared plus 25xy plus 25y squared. And if I factor that, I would get 4x plus 5y times 4x plus 5y. In the denominator, I would have a 4y, and then if I factor x squared minus 25y squared, that's a difference of squares, so I can write that as x minus 5y and x plus 5y. Then, moving on to the second factor, I have already factored out an 8, but I still have to factor the x squared minus 4xy minus 5y squared. And when I factor that, I would get x plus y times x minus 5y. And in the denominator of the second factor, we already have that factor, so I'm just going to copy it down. Now, this is a little bit messy, but it's still the same procedure. You factor, and then you try to cross off what the denominator and the numerator has in common. And then also, for those of you who are not quick at factoring yet, you may need to do some of this work on scratch paper to figure out all these polynomials in factored form. Okay, so now let's start crossing off what they have in common. I see that there is a 4x plus 5 in common. I can cross that off. There is a x minus 5 in common on the top and the bottom. We can cross that off. And there is a y in common. I can cross that off. And then I can cross the 4 and the 8 off. And the 8 over 4, I can rewrite that as just a 2 in the numerator. So what we have left over after crossing off everything that they have in common, I have this 2 left, I have this 2 left, I have the x plus 5y left, and this factor here left. So when I write down my final answer, I'm going to have 2 times 2, whoops, and I also have 4x plus 5y and x plus y. So when I write down my final answer, I'm going to have the 2 times the 2 in the top, which is 4, times 4x plus 5y, and I still have the x plus y up there as well. That's what's left in the numerator, and then in the denominator, I have x plus 5y, and then 16x squared plus 20xy plus 25y squared. So here is my final answer. It's a big mess, but it's not hard. It just takes time. You just have to take your time, do your factoring on some scratch work, and then cross off everything they have in common on the top and the bottom. Now, when we divide rational expressions, we're going to use the same procedure that we use as when we divide numerical fractions. So if you think back, if I asked you to take 5/8 and divide by, say, 4/30. Then I would take the first fraction and multiply it by the reciprocal of the second fraction. And then I would factor everything on the top and the bottom. So I have 5 times 30, which is 3 times 2 times 5. And that would all be over 8, which is 2 times 2 times 2, and 4, which is 2 times 2. And then I would cross off anything that they have in common. So they have a 2 in common here, and it looks like that's it. So what would be left on the top would be 5 times 5, which is 25, times 3, which is 75, all over 2 times 2 times 2 times 2, which is 16. And this would be my final answer. So we're going to use that same procedure when we divide rational expressions, where we take the first fraction and multiply it by the reciprocal of the second fraction, and then we cross off what they have in common and simplify. So in this first example, we have 3a squared y all over 5ay squared, and I want to multiply that by the reciprocal of 9a to the third y squared over 15ay to the fourth. So when I reciprocate that, I get 15ay to the fourth on top and 9a to the third y squared on the bottom. So now we start looking to see what we have in common that we can cross off. So I have a y squared and a y squared on the bottom, which makes that a y fourth. And I'm going to cross that off with a y fourth on the top. So I get rid of 4 y's on the bottom and 4 y's on the top. Now I have 3 a's on the top, a squared and an a, and I have this a3 down here that I can cross off. And then I have 3 that I can get rid of a 3 in the denominator, because that 9 is 3 times 3. When I cross off a 3, I'm left with a 3. And this 5 can cross off with this 15, and I'm left with a 3 up here as well, because 15 can be written as 5 times 3, and I cross off the 5's and I'm left with the 3. And now if you notice, I can also cross off, I have a 3 upstairs and downstairs that I can cross off. And it looks like what's left after I cross off everything that's in common, I have a y upstairs and an a downstairs. So my final answer would be y over a. Okay, for the second example, we're going to do the same thing again. I have x minus 5 over x squared minus 10x plus 25. And I'm dividing that by x minus 5 over 4, so I need to multiply by the reciprocal, which is 4 over x minus 5. And now what I'm going to do is I'm going to factor everything and cross off what they have in common. So x minus 5 on the top in the first fraction, we can leave that alone. That's as factored as it's going to get. In the denominator, I can factor that as x minus 5 times x minus 5. And then in the second fraction, there's nothing to factor, so I'm just going to carry that down. And now I'm just going to start crossing off everything that they have in common. So I have an x minus 5 in common on the top and the bottom, and that's all there is in common. I cannot cross off the x minus 5 and the x minus 5 in the denominators. It has to be from top to bottom. It can't be a cross that we cancel. It has to be top to bottom. Okay, so what's left over is 4 on the top, and then x minus 5 and x minus 5. So here is the final answer. Okay, the last example for division, I'm going to factor the top of this first fraction, 16t squared minus 1. That's the difference of squares, so that's 4t minus 1. 4t plus 1. In the denominator, I can factor 12t squared plus 11t plus 2 as 4t plus 1 and 3t plus 2. Now I need to multiply by the reciprocal of the second fraction, which would make it 27t to the third plus 8 on top, and 64t cubed minus 1 in the denominator. So I'm going to copy the first fraction down because that one's already all factored. But I still have to factor the second fraction. Now the second fraction in both the numerator and the denominator has the sum of cubes in the numerator and the difference of cubes in the denominator. So we're going to have to use our formulas to factor those. So you may want to get some scratch paper and do that off to the side. When you factor 27t to the third plus 8, using the formulas, you get 3t plus 2 times 9t squared minus 6t plus 4. In the denominator, when you factor 64t to the third minus 1 using the formula, you're going to get 4t minus 1 times 16t squared plus 4t plus 1. Now, let's cross off what they have in common and see what we have left. We have a 4t minus 1 in common. We have a 4t plus 1 in common. We have a 3t plus 2 in common. And so what's left is 9t squared minus 6t plus 4 all over 16t squared plus 4t plus 1. And so this is our final answer. Okay, now we're going to talk about addition and subtraction of rational expressions. Now, when we add or subtract numerical fractions, we have to find a common denominator. So, for example, if I gave you 5 over 8 plus 1 over 16, I would have to find a common denominator, and I do that by breaking down the denominators. So 8 can be broken down as 2 times 2 times 2, and 16 can be broken down into 2 times 2 times 2 times 2. And now we look to see what they have in common and what each denominator needs in order to make a common denominator. So over on the right-hand side, I have 4 2's, and on the left-hand side, I only have 3 2's. So that means I need to multiply a 2 in the denominator, but whatever I do to the bottom, I also have to do it to the top to keep that fraction equivalent. And so now I would have on the top 10 over 16 plus 1 over 16, and now I have a common denominator, and I can add the numerators. So my final answer would be 11 over 16. So we're going to use that same method when we add or subtract rational expressions. We need to find a common denominator. So the first step is to factor the denominators to see what we need to make common denominators. So I have 5x minus 3 over, and then I'm going to factor 4x plus 4. Well, I can factor out a 4, and I'm left with x plus 1. I can't factor x plus 1. That's as factored as it's going to get. Now, if I look at my denominators, they both have an x plus 1 in common. However, the fraction on the right doesn't have a 4 in the denominator. So I need to multiply the denominator and the numerator by 4 in order to make a common denominator. So now I have 5x minus 3 minus 4 times x minus 1 in the numerator all over my common denominator, which is 4 times x plus 1. And now I just have to simplify the numerator. So I have 5x minus 3, and I'm going to distribute that negative 4, so that gives me a minus 4x plus 4 all over 4 times x plus 1. When I simplify the numerator, I have 5x minus a 4x. That gives me an x. And I have a negative 3x and a positive 4x, which gives me a plus 1, all over 4 times x plus 1. And now I have an x plus 1 on the top and the bottom that I can get rid of. So my final answer is going to be 1/4. Okay, my next example, I have z minus 3 in the numerator, and in the denominator I have 2z minus 5. That cannot be factored. So now let's move on to the second fraction. We have 3z minus 4 in the numerator, and then in the denominator we have 10 plus 6z minus 4z squared. Now when I factor, this is a personal preference, this isn't something you have to do, but when I factor, I like to write my polynomial in descending order. So I'm going to rewrite this as minus 4z squared plus 6z plus 10. So all I'm doing at this point is just rewriting it in descending order. I also do not like to have negatives in front with my leading coefficient when I factor, and again, that's just a preference. So what I'm going to do is I'm going to rewrite everything over again, because I like to make this as easy as possible, and I'm going to factor out a negative from the denominator so that my leading coefficient is positive for when I factor. I'm going to pull out actually a negative 2 because all terms have a negative 2 in common. And what I would have left is a positive 2z squared minus 3z minus 5. Now I'm subtracting and I have a negative here, so that turns it into a positive. So I have z minus 3 all over 2z minus 5 plus, because I have a double negative, 3z minus 4 all over 2 times 2z squared minus 3z minus 5. So now I'm going to finish factoring that 2z squared minus 3z minus 5 in the denominator. To save myself some room, what I'm going to do is I'm just going to replace that 2z. I'm just going to replace down here my factorization. So when I factor that 2z squared minus 3z minus 5, I'm going to get 2z minus 5 times z plus 1. Now, if you notice, all we did so far is factor and try to set this up. We still have to find a common denominator. So if you notice, in this fraction here, I have a denominator, I have a factor of 2z minus 5, and I have a factor of 2z minus 5 here as well. What's missing is the 2 and the z plus 1 in the first fraction. So on the top and the bottom of the first fraction, I'm going to multiply by 2 and z plus 1. So now I have a common denominator. So now let's multiply the 2, the z minus 3, and the z plus 1 in the numerator of the first fraction, and we can combine it with our 3z minus 4 in the other numerator in the second fraction. And since I'm running out of room here, I'm going to let you guys do the scratch work off to the side, and I'm just going to tell you what that is when we multiply. If I multiply 2 times z minus 3 times z plus 1, you're going to get 2z squared minus 4z minus 6, and that's going to be all over our common denominator. And that's going to all be added to the 3z minus 4 with the common denominator downstairs. So if I combine like terms, I have 2z squared. I have a negative 4z and a positive 3z, so that gives me a negative 1z. And I have a minus 6 and a minus 4, that gives me a negative 10. And that's going to all be over my common denominator of 2 times 2z minus 5 times z plus 1. And the last step is then to see if you can simplify. So then if I factor 2z squared minus z minus 10, I would get 2z minus 5 times z plus 2. And that's all over 2 times 2z minus 5 times z plus 1. Now I can cross off what they have in common, and so my final answer is going to be z plus 2 all over 2 times z plus 1. So that was a fairly lengthy problem, but it was the same procedure. You want to factor the denominator, find a common denominator, and then combine the top and keep the denominator the same, and then simplify it if you can. Now I want to remind you, because I was running out of room, that this step right here, when I multiply that, that's this answer right here in the top. And I did that out separate on a piece of scratch paper. Now, if you guys want to check my work and convince yourself that that's true, since I skipped a couple steps there for purposes of room, you can go ahead and do that. But that's what this purple step is here. I took 2 times z minus 3 times z plus 1, and I got everything here up on the top. And then I added it to the 3z minus 4 here. Okay, next example, I have a whole number and I'm adding it to a rational expression. This one's actually a lot easier because the whole number is kind of like a blank slate and I can create whatever denominator I want. I want a denominator of 4 minus t. So I'm just going to take this 3 over 1 and multiply the top and the bottom by 4 minus t. And then I'm going to add that to 1 over 4 minus t. So on the top, I have 3 times 4, which is 12, and 3 times a negative t, which is a minus 3t, and I'm going to add that to 1 all over a common denominator of 4 minus t. So I have a minus 3t, and when I add the 12 and the 1, that gives me a 13, and that's all over 4 minus t. And that won't simplify. You can try it if you want, if you're not sure. I know from experience by looking at that that's not going to simplify, but you should always double check and make sure and try to factor it and see if you can cancel it with something in the denominator. Okay, this last example for adding and subtracting rational expressions, it's the same procedure we've been doing so far, only we have 3 fractions now. I'm just going to factor everything in the denominator. So in the denominator of the second fraction, because I can't simplify anything in the first fraction, but in the second fraction, I can factor out a negative 3, and that would leave me with an x plus 3 on the inside. And that would leave me with an x minus 3 on the inside. And then in the last fraction, I can pull out an x, and that would leave me with an x minus 3, and I have 3 on top. So notice, in the second and the third fraction, I have an x minus 3, but I don't have an x minus 3 in the first fraction. So I'm going to multiply the top and the bottom of the first fraction by x minus 3. Now, notice, in the second fraction, there is no x in the denominator. But the first and the third fraction have an x in the denominator. So I'm going to multiply the top and the bottom of that fraction by x. And then the last thing I notice is that the first fraction and the third fraction don't have a negative 3. So I'm going to multiply the top and the bottom by the first and the third fraction by negative 3. And so now I have a common denominator. My common denominator is negative 3x and x minus 3. So now I'm going to multiply all the numerators and add them together. So in the first numerator, I have a negative 3 times 1 times x minus 3. In the second numerator, I have x squared. And in the third numerator, I have a negative 9. And that's all over my common denominator, which is a negative 3 with an x and an x minus 3. Now I'm going to distribute that negative 3. So I have a negative 3x plus 9. And then I have plus x squared and a minus 9 all over negative 3x, x minus 3 in the denominator. The 9 and the negative 9 add to give me 0. And I'm left with x squared minus a 3x all over negative 3x times x minus 3. Now we're almost done. The top, or the numerator, I can factor that, and it will simplify with the denominator. I can rewrite the numerator, if I factor it, as x times x minus 3, and my denominator is negative 3x times x minus 3. So they have an x minus 3 in common, they have an x in common, and so what's left is 1 over negative 3. So that big mess with all three of those fractions, when I add them up, I get my final answer to be negative 1/3. Okay, the last topic in this lesson, we're going to talk about simplifying complex fraction. And a complex fraction is when you have a fraction within a fraction. So how you want to handle this to simplify it is you want to find a common denominator of all the mini fractions that are within the big fraction and multiply the top and the bottom by that common denominator, and it will clear everything out and really simplify it. So if you look, this is what I'm calling my mini fractions. This is a mini fraction, this is a mini fraction, and this is a mini fraction. The whole entire thing is my big complex fraction. So what I want to do is I want to look at all my little mini fractions and look to see what my common denominator is. So I have x's and y's. So what I'm going to do is I'm going to say, well, my common denominator is x and y. So I'm going to multiply the top of my fraction by xy and the bottom of my fraction by xy. I can do this because if I multiply the same thing on the top and the bottom, really I'm multiplying it by 1 and I'm not changing the value of the fraction. Okay, so when I multiply x, y, and I can write a 1 over that if I want so that it lines up with my other fraction, xy over 1 times 2 over 1 minus 1 over xy. So I'm just setting it up so my fractions line up. Okay, now when I multiply the top, I have xy over 1 times 3 over x. If I have the same thing on the top and the bottom of a fraction, I can cross it off. So this x and this x is the same, so I can get rid of that. And what I'm left with is y times 3 on the top over 1, which is just 3y. Then when I take xy over 1 times 2 over 1, that's going to give me 2xy. Then when I take xy over 1 times a negative 1 over xy, I can cross off the xy's, and I'm left with just minus 1. So this big mess, what we started with, 3 over x, all over 2 minus 1 over xy, is simplified to this one fraction. And rather than having multiple fractions within fractions, we can write it as one fraction. Okay, so the next example, again, we have x's and y's. So I'm going to multiply the top and the bottom by xy so I can clear out my complex fraction. So I have to take xy over 1 times 3 over x. When I do that, I can cross off the x, and I'm left with just 3y. So let me erase this and do the next one. Now I got to take xy times 1 over y, and now I can cross off the y's, and I'm left with just x. Now on the bottom, I'm going to take xy times 1 over x, and I can cross off the x's, so I'm left with just y. So let me clear this out so I can do the next one. And now I'm going to take xy times 2 over y, and I can cross off my y, and I'm left with just 2x. So now this will be my final answer. Okay, the next fraction, I have 4 mini fractions. 1, 2, 3, 4, all contained in this one big fraction. So if you look at all the mini fractions, my denominators are x minus 1 and x plus 1. So what I'm going to do is I'm going to multiply this big mass on the top and the bottom by x plus 1 and x minus 1. I got to do the same thing on the top and the bottom. So now I'm going to take x plus 1 times x minus 1 times this first mini fraction. When I do that, I have an x minus 1 that crosses off this with this x minus 1. So I'm left with x plus 1 times x plus 1. This is what's left, the x plus 1 and the x plus 1, when I'm looking at multiplying by the first mini fraction. Okay, now let's delete that so then we can look at the next one and it doesn't get cluttered. Now I'm going to take x plus 1 times x minus 1 times this mini fraction. When I do that, the x plus 1's disappear, and I'm left with x minus 1, x minus 1. This is what's left, x minus 1 and x minus 1, because I crossed off the x plus 1's. Okay, so let me erase that. Okay, now let's do the bottom. Now I'm going to take x plus 1 times x minus 1 times this mini fraction. When I do that, I have an x minus 1 on the bottom here and an x minus 1 on the top here, so I can cross those off, and I'm left with x plus 1 times x plus 1. And then the last step, I'm going to take x plus 1 times x minus 1 times this mini fraction. And because this is a minus here, it's going to be a minus over here. I have an x plus 1 in the denominator here and an x plus 1 in the numerator here. So those cross off, and I'm left with x minus 1 times x minus 1. Now, I'm going to multiply this out, and that is going to give me x squared plus 2x plus 1. Now I'm going to multiply this out, and this is going to give me x squared minus 2x plus 1. And that's all over. I'm going to multiply this out now. That gives me x squared plus 2x plus 1. And I'm going to subtract x minus 1 times x minus 1 is x squared minus 2x plus 1. So I have an x squared and an x squared upstairs. That gives me 2x squared. I have a 2x and a negative 2x. That disappears. And I have a 1 and a 1, and that gives me a 2. Downstairs, I have an x squared, and I'm subtracting an x squared. So that disappears. I have a 2x, and I'm subtracting a negative 2x because that gets distributed. I have a 2x, and I'm subtracting a negative 2x. That's going to give me a 4x. And then when I take the 1 and I subtract the positive 1, that's going to give me 0. So I'm left with 2x squared plus 2 all over 4x. In the numerator, I can factor out a 2, and I'm left with x squared plus 1. In the denominator, I can have and factor out a 2. And that way I can cancel out the 2's, and I'm left with x squared plus 1 all over 2x is my final answer. This part down here gets a little bit tricky because you're subtracting this whole thing right here. So don't forget, you have to distribute that negative. So that becomes, when I distribute that negative, a minus x squared, a positive 2x, and a minus 1. So be careful with distributing those negatives. Okay, last example for simplifying complex fractions. My common denominator for all my mini fractions is going to be a minus 5 times a plus 1. Because if I factor, here are my mini fractions, I have 1, 2, 3. If I factor the denominator, x squared minus 4a minus 5, I'm going to get a minus 5a plus 1. So if I look at the other denominators, that's exactly what I have down there. I have an a minus 5 and an a minus 1. So what I'm going to do is I'm going to multiply the top and the bottom by a minus 5 and a plus 1 on the top and the bottom of my complex fraction. And this is my common denominator. When I multiply this times this whole thing is going to cancel with the denominator because a squared minus 4a minus 5 is a minus 5 times a plus 1. It's the same thing, just factored. So I'm going to be left with 5 up top. Now in the denominator, when I multiply this times the first mini fraction, I can cross off my a minus 5's, and I'm left with 3 times a plus 1. This and this is what I'm left with because I cross off the a minus 5. Okay, now when I take and multiply by the second mini fraction, I can cross off the a's plus 1s because there's a plus 1 in the denominator of the mini fraction and then an a plus 1 up here, and I can cross those off, and what I'm left with is the a minus 5 times the 2. Okay, so in the denominator now, I have 3 times a plus 1, which is 3a plus 3. And then I have 2a minus 5, which is 2a minus 10. When I combine like terms, I get 5a and a minus 7. And so this is my final answer because there is nothing that I can factor out of the numerator and the denominator that is same, so that I can cancel them and simplify. So that's as simplified as we're going to get, and so that is the final answer.